Hi everyone, I am from Group 8. So today I will present the analysis of our group function, which is fx equal to 1 over 3x cubed plus 1 over 2x squared minus 6x plus 8. So this is the question where A, I need to find the critical number of fx, B, I need to find the point of which fx has a relative extremum, minimum and maximum, the interval on which fx is increasing or decreasing, and D, I need to plot a graph using GeoGebra. First, I found two derivatives needed for this analysis. The first derivative, I got x squared plus x minus 6, and the second derivative, I get 2x plus 1. So how to find the critical number of fx? I set the first derivative is equal to 0. So x cubed plus x minus 6 is equal to 0. And I found the critical number is x equal to 2 and x equal to negative 3. Next, I found a relative extremum for fx by insert the critical number into the original function. So when x equal to negative 3, fx I got 43 over 2, and x equal to 2, fx equal to 2 over 3. The maximum point is negative 3, 43 over 2, and the minimum point is 2 over 3. For C, we need to find the interval on which fx is increasing or decreasing. The function is increasing on negative infinity to negative 3 and 2 to infinity. And the function is decreasing on the interval of negative 3, 2. Next, we need to find the concavity. We need to use the second derivative. We need to equal it to 0. So 2x plus 1 equal to 0, and I got x equal to negative 1 over 2. So we need to find the concavity, either is concave down or concave up. In order to know either we have the inflection point or not. For the interval negative infinity to negative 1 over 2, we got concave down, and negative 1 over 2 to infinity, we got concave up. So when they have a difference of concavity, we can get the inflection point, which is negative 1 over 2, 11.11. And finally, let's look at the graph that I plot using GeoGebra to verify everything. As you can see on the screen, when I put the function fx equal to 1 over 3x cubed plus 1 over 2x squared minus 6x plus 8, the graph perfectly match my manual calculation. So first, look at the peak here, x equal to negative 3. This is exactly the relative maximum point that I calculated, which is negative 3, 43 over 2. And same for the minimum point, as we get two over 3. Also, if you look at the right in the middle at x equal to negative 1 over 2, we can see that the curve is changing. It goes from concave down to concave up. This confirms the inflection point that I found earlier. It's great to see that the calculus theory and the actual graph are identical. So that's all for my presentation. Thank you.
Alright, for question 2, two parallel sides of a rectangle are being lengthened at the rate of 2 inches per second, while the other two sides are shortened in a such way that the figure remains a rectangle with constant area 15 inch square. What is the rate of change of the perimeter when the length of an increasing side is 5 inch, 10 inch, and what are the dimensions when the perimeter ceases to decrease? Draw the rectangle and label L and W as the length and width Alright, so from the question, we can get the information of dl over dt equal to 2 inch per second. Alright, for perimeter, we know that this is L, W, L and W. So for perimeter, we have to add all of it and get into the equation. For area, the equation is length multiplied by the width, and we can equate to 50 inch square. So first, we have to express W in terms of L. From this equation, we can make W as the subject, so 50 over L. Next, we have to substitute the W in P equation. So from P equal to 2L plus 2W. So substitute the W in that equation and we will get 2L plus 100, L negative 1, or L or 100 over L. Next, we will differentiate P with respect to time using the chain rule. So we want the dP over dt, so we will differentiate the P equation and multiply with dl over dt as given from the question. So 2 minus 100, L negative 2 multiplied by 2, and we'll get 4 minus 200 over L square, or 4 minus 200, L negative 2. So for A, the length given is 5. So dP over dt, and so we substitute 5 into the equation, which is the dP over dt. So we will get negative 4 inch per second, means that the perimeter is decreasing by 4 inch per second. For B, the length given is 10, so substitute 10 and we'll get 2 inch per second, means the perimeter increased by 2 inch per second because it is positive while the A is negative. And for C, how to know the dimension when the perimeter ceases to decrease, means that the dP over dt equal to 0. So we will equate the dP over dt equal to 0 and calculate and settle for the L. And we will get L equal to 532 inch or 7.07 inch. So to test the length given or the length we obtain, we can insert into the equation of W, and we'll get that 532 inch is more than 0, means it is the minimum. So the dimensions when P ceases to decrease when it's at the minimum L, 532 inch.
For the question number 3, the information gives us a total cost of product C, which is equal to 1 over 4x squared plus 35x plus 25, and it gives another information, price per set, equal to 15 minus 1 over 2x, and we give another variable for quantity of radio, which is x. First, we need to find the total radio sold, which is the quantity multiplied with the price per set. And we get a 50x minus 1 over 2x squared. For the 3A, it asks what should be the daily output to obtain a maximum total profit. To get the maximum total profit, we need to minus the total cost of product C with total sold. So the total sold is 50x minus 1 over 2x squared minus with total cost of product C 1 over 4x squared plus 25x plus 25. We get 50x minus 3 over 4x squared minus 25. To find the x, we need to do a first derivative test, which is we get 15 minus 3 over 2x. Find the x, we have to equal it to 0. We get x equal to 10. To check whether x is maximum, we have to do a second derivative test, and we get negative 3 over 2. And we equal it to 0, we get negative 3 over 2 is less than 0, therefore it's a maximum. Therefore, daily output should be 10 radio set to obtain a maximum total profit. For the question 3B, we need to find the average of the product. To find the average, we need to divide the cost of production divide with quantity of radio. So we get the average is 1 over 4x plus 35 plus 25 per x. To get the quantity of radio x, we need to do a first derivative test, which is we get 1 over 4 minus 25 over x squared. We equal it to 0 and we get x equal to 10. To check whether the x is minimum, we need to do a second derivative test. Then we get 15 over x cubed. We equate 15 over x cubed to 0. So we get the x is 1 over 20, which is more than 0. Therefore, it's a minimum output. The cost of production is a relative minimum at the output.
Hi and Assalamualaikum everyone. Today I will be presenting question 4, which is we need to evaluate each of the following limit using L'Hopital. So for the first one, we substitute x equal to 0. The numerator sin 3x becomes sin 0 and the denominator for x also becomes 0. Since this gives the indeterminate form 0 over 0, we can apply L'Hopital rule. So we need to differentiate both numerator and denominator separately. We got derivative of sin 3x is 3 cos 3x and derivative of 4x is 4. Now we need to substitute x equal to 0 again. We got expression, so the expression become 3 cos 3 times 0 over 4. Cos 0 we got equal to 1, so the final answer would be 3 over 4. Now for second question, look at what happened when n goes to infinity. Both the numerator and denominator go to infinity, so this is an infinity over infinity expression. So we can use L'Hopital rule. First, we need to differentiate once. The numerator becomes 6e power 2n and the denominator becomes 8n. If we check again, it is still infinity over infinity, so we can apply L'Hopital rule one more time. So after differentiating again, I get 12e power 2n over 8. Since e power 2n grows really fast as n increase, the whole expression goes to infinity. So the limit is infinity. The next question, for this one, when x goes to 0 from the positive side, x squared goes to 0. But ln x goes to negative infinity. So I need to rewrite it as a fraction to use L'Hopital rule. I rewrite it as ln x over 1 over x squared. Now this becomes negative infinity over infinity. So we can use L'Hopital rule again. So first one, we differentiate the top and bottom. I get 1 over x over negative 2 x power negative 3. When we simplify this, it becomes negative x squared over 2. So as x goes to 0, x squared goes to 0. So the whole expression goes to 0. Therefore, the limit is 0. For the last one, both n and e power 2n go to infinity as n increases. This is infinity times infinity, which is not an indeterminate form. So L'Hopital rule doesn't apply here. So the limit is infinity. So that is all from me. Thank you for watching.